Okay.
But she's like,
Oh, you can't see
yeah,
anything, can you?
guys, I know you have other classes, but
I don't understand. I was on track with the rest of the class as far as like what we're talking about in class, and I still have 100 pages to read. So I don't understand how she expects us to set that up. And then 10 of us stuff. Yeah, it's ridiculous.
Yeah, I know what you mean, guys.
cough documentary.
What is the magnitude of the acceleration? And B, where is the cart when the magnitude of the acceleration is greatest? What is the cart speed then?
Okay.
And
So what are we gonna do?
So
So what's our position functions?
Don't.
18.
Okay, so we've got
S. What is differentiation?
Yeah, it's for the function. The guy who wasn't your partner.
what's our domain, by the way?
What? Domain?
Yeah,
5 to 0 to 5.
0 to 5.
Yeah.
2 to 5.
That makes
Who
sense.
needs 0 and 1? I know.
Okay, so we want to find, what are we looking for here? What is the cart's maximum speed? Okay, so this is position. What speed can be related to?
Position, I don't know.
First.
First derivative of position is what? Velocity, right? Okay, so velocity as a function of time is going to be what if I differentiate this? You got to use
Negative
chain rule.
sign.
So we're going to get negative.
Negative number. It's different. The number is a
Okay,
different
Well,
number.
sorry, mine's different.
Mine's 12.
Derivative of cosine is sine times what?
Pi.
Pi. So I'll just put the pi out front with 18.
18
constant.
pies.
Okay, there you go. So that's our velocity function, right? Now that's what we're trying to maximize. Okay? So what are we going to do to maximize that function? What would we always do?
Pies.
Yeah. Just figure out where sign is equal to 0.
No,
Oh, darn.
no, because
pi
that
is
would be,
advanced.
this is the derivative of position.
Oh, so
Look
we
what
need to
they're-
take the derivative of that.
Uh-huh, yeah, see, they're wanting us to, they're wanting us to maximize speed, right? Okay, so we've got to take the derivative of v. So we could call that, if we want to, we could call that v prime of t. It just happens to be acceleration, but it's the derivative of velocity, right? So what's that going to give us?
Negative 18 pi pi
Pi.
Negative 18 pi squared
pi
cosine pi
squared.
t, yeah.
See, I was a little confused. I don't recognize.
So then where is v prime equal to 0?
Just from cosine.
When cosine is 0. Right, okay. So let's look at our, if we look at our unit circle here,
So that's the 0 and 1.
as t goes from 0 to 5, we're going to go, what are we going to do? So we're going to start here and we're going to go pi, 2 pi, 3 pi, 4 pi, 5 pi, right? Does that make sense? Okay. So we want to know where are the zeros of that going to be. Well, where is cosine equal to 0?
Pi over 2 and 3 pi over 2.
Okay.
So why
And
would I change that?
5 pi over 2 and 7 pi over 2 and 9 pi over 2 on our domain, right?
Does the pi next to t change that though, or is it just
Well, no, because
that's where?
we want to know when this is like theta, isn't it?
Yeah.
So when theta is equal to pi halves or 3 halves pi, right? See what I'm saying? As t goes from 0 to 5, theta is going to go from 0 to 5 pi, right? So this is going to equal, so then we know that v dot equals 0 when pi t equals one of several different options,
Well,
right?
don't we need only one of those though, effectively for the problem?
Sure, but they're gonna wanna know, if you keep looking at it,
Where is it at?
Don't you have to
when is the car moving that fast? Right, so we're gonna wanna know all
You're
of
gonna
them.
need every single time.
Don't you have to stop at 3 pi over 2? Just instead of like, you know, you said we keep going to 5.
No, we can go clear to 5, right?
Yeah,
I thought,
Because the domain goes from, right, it's gonna go from 0 to 5, right? So then this is gonna give, so this is gonna be true when pi over t equals pi halves, 3 pi halves,
Oh, yeah.
5 halves pi, 7 halves pi, or 9 halves pi. So those are the cases where t equals 1 half, 3 halves, 5 halves, 7 halves, and 9 halves, right? Right, everybody with me?
Oh, yeah,
Okay. So those are the values of t, and those are within our domain. Okay. And there's an infinite number of them on the infinite domain, but we're restricted. Okay. Good. So then, how fast is it going there? Wants to know, right? Oh, when is it moving that fast? First of all, are all these going to be maximum? We should probably find out. Okay. If we were to like make our table here, right, which we can do. So we'd have t v and v prime. And are we gonna do v double prime? I mean, we could.
Why not? That'll just make it 18 pi squared cosine, or sine.
We could. It's fine. So if we want to do, I mean, that's possible. We could use the second derivative test. V double prime of t would just equal what? So derivative cosine is minus sine, so we're going to get a positive 18 what?
Pi cubed,
Pi cubed.
sine pi t.
So then the sine of the second derivative is just going to be the sine of pi t, right? Okay, just multiplied by a positive constant. So let's put in all of our critical numbers. So what do we get? We got critical numbers at 1 half, 3 halves, 5 halves, 7 halves, 9 halves. And those are all zeros of, oops, sorry, v prime. Right? Okay, so we better add, I guess, our other. Okay, so then what's going to be the value of sine of pi t at each of these places? So what's the sine of pi halves?
Or
Positive or negative?
Positive.
Positive. Okay, so that's positive. Sine of 3 halves pi?
Negative.
5 halves? 7 halves? 9 halves?
Positive.
Okay, so then what's that telling us? That's telling us that this is a minimum, right? This is gonna be a maximum. That's a minimum. That's a maximum. And that's a minimum, right? There is one kind of tricky thing going on here, though. And you almost have to be a physics type to get this. They're asking where the cart has not its maximum velocity, but its maximum speed. Right? So let's talk about this one for a second. Right? It's a difference, right? Maximum velocity, remember, velocity is a vector quantity, right? So if I'm moving in the positive direction, velocity is positive. If I'm moving in the negative direction, it's negative, right? But speed is speed. Speed doesn't have a sign, right? Speed is the magnitude of velocity. So the point I'm making here with this one is, even though these are minima, could they be maxima for speed? They could, right? In fact, if we evaluate the function at all those places, what are we gonna get? If we go back to the original velocity function, we get negative 18 pi times sine of pi t. So, oh, did we? No, we're good, never mind. So then, if I evaluate this at pi halves, sine of pi halves t is 1, right? So I get negative 18 pi, right? Everybody agree? What do I get at 3 halves pi? Well, I'm going to get sine is negative. Negative times negative is positive. 18 pi. What about here? That's going to be negative 18 pi, negative 18 pi. So what's the maximum speed? 18 pi. And where does it occur? In all those places, right? All this means is that it's going backwards, right? We got this spring that's pulling this cart back and forth against the wall. I should get this way for you guys, right? Back and forth against the wall. And so it's going to be at it's going like this, right? It's got this spring. So it's going to be at its maximum positive velocity on the way out, maximum negative velocity on the way back. But the speed's the same both times, right?
So. You can't just like put in 18 pi or 12 pi, you have to actually have to.
You want it around pi, there's 10.
Oh, it does?
Yeah.
Oh, okay. That's
Isn't that?
okay, so going back then, so then we've got, what is the maximum speed? 18 pi. When is the cart moving that fast? At t equals 0.5, 1.5, 2.5, 3.5, 4.5 seconds, right?
So you put all of those, or just?
Yeah, those are all, right, at all those times it's moving that fast. Where is it then? Well, where would I go to find out what the position is? First one, my position function. Well, what's going to be the cosine of any multiple of pi halves? Any integer multiple of pi halves? I said that wrong. An odd multiple of pi halves. Right, so it's going to be at 0, isn't it? Right, the cosine of pi halves is 0, cosine of 3 halves pi is 0 the whole time, isn't it? Right? So what's that mean then? Well, that means that it's in its rest position, because what's really going on is we're starting this car, there's this spring attaching it to the wall, and I'm either going to pull it out here and let it go, or push it down here and let it go, right? Either the spring is going to start compressed or stretched, doesn't matter.
So wherever
Either way, it's going to push it in the opposite direction. But its its neutral rest position would be at 0, and that's where it's going the fastest, right? Okay. So, but you don't even have to know that about the physics. You would just plug it in there and see where is it moving its fastest. Well, it's going to be at these times, and the position function is giving us back 0 for all those.
Yeah.
Right? What is the magnitude of the acceleration then? Okay, well, acceleration is v double prime, right? So we'd have to actually plug in values for that, but that's okay. We're going to get the same answer the whole time, aren't we? We're going to get 18 pi cubed times 1, or negative 1, right? At pi halves, it's going to be positive 1. At 3 halves pi, it's negative 1. So we're either going to get positive 18 pi cubed or negative 18 pi cubed. But the magnitude, what's a magnitude mean?
Doesn't matter.
Magnitude just means the size of the number, so its absolute value, right, is 18 pi cubed. Okay?
So I don't know what this one.
I'll check.
This one just says simplify your answer. It doesn't say it around.
Ready?
For maximum
Oh, I put,
acceleration.
not 18.
I'm curious to see what they
Alright,
decided
ready?
to do.
Oh, it doesn't like it.
So what do they want with that one?
What'd you try?
Simplify it. So just 12 pi cubed or whatever.
No. let's
No,
look
I
at-
just tried that.
I'm gonna try to the 10th.
Well, that's kind of doofy. You have to guess. That's-
Yes.
Seriously?
No, it's not that. It's not to the 10th.
What?
Answer.
Let's see this. So it says, all right.
Round to the nearest 10.
Yeah, so the first two are around the nearest 10th, the next. two
So
are
the maximum speed of the cart here is just going to be, what, 18 pi squared for me, right?
18, just pi. So 56.4.
Oh, 18 pi, right. Okay. So what is that?
56.4.
Okay. So I have check.
Haha.
It's-
Is that
No,
right?
no,
That's
no,
pretty
no,
good.
no, it's 56.5.
Oh, yeah, I'm stupid, sorry. Crank.
Okay. Nice work. All right. The time at which the cart has maximum speed
ready?
is
0.5.
1.5, 2.5.
Make sure you put commas.
Yeah,
Comma.
and don't mix it up.
comma to separate answers. Okay.
1.5.
They have to be in order too?
I don't know.
I doubt it.
Probably. No, this is
Enter.
Well, it'd be safer to do it that way.
Yeah, just.
Okay,
in case.
good, well
Or-
done, all right. So I feel,
Zero.
I feel affirmed.
No,
Until you get them all wrong.
I like the
Yeah.
one where it just says no.
Yeah, no.
Okay, the
No.
magnitude
Should just
of
be
the
18.
acceleration when the cart has maximum speed is,
Try 18.
simplify your answer. Why is it not saying
Yeah.
round to anything? So it should be 18 pi squared, right?
Cute.
Square or cube?
Cute. You said it was
Cubed. Is it cubed or is it squared?
I don't think it's wrong.
Yeah, I know, I just-
Velocity? No, I think it's only squared.
Yeah, because like when you take derivative, it'd be 2 setting 1, and then you multiply the pi
You
by pi
got
is
it
square.
down. Oh, yeah, it would be square.
Yeah,
Squared.
Alright,
Who
River,
quiz?
Okay.
your turn, put
You
it
gotta
in.
try it.
So
Put
18
squared.
12 pi squared didn't work, so I'm gonna
times
try doing it.
pi squared.
118.
Oh.
Oh crap, that's my final check, I can't do it. No, it's not that, it's not that, I already tried that.
Alright.
Uh,
Who has
So,
checklists?
Checks left.
well,
Jonathan?
Oya does.
Nine.
So here, put in 177.7. You can double check me if you want.
Yes.
Yes.
Ah.
Is the derivative?
Oh no, we're on his
That's
final
easy.
check.
Well, it says it's on the second derivative.
So, yeah, what,
It's a derivative
did
of
I
velocity.
misremember this? Isn't the acceleration,
No,
yeah,
it's
it's,
V
oh,
prime.
what, we do have pi cubed. But that's wrong, isn't it?
Wait, no, wouldn't it be?
Oh, wouldn't it be
prime?
negative? Would it be negative? Or no, cause it's.
Why would it be negative?
How did we make a mistake here? How did we get pi squared here?
Because
Well, we got everything else right.
Oh, that's v prime,
Yeah, which is
Yeah.
acceleration.
which is acceleration, right? Oh, we were looking at the wrong one, right? And
that's
so-
what we still
Wait,
don't know
no,
how to
wait.
put it in. We changed it.
We
Right.
had to put in 18 pi squared.
Right, so I did put in 18 pi squared.
Yeah.
Okay.
But did we,
And I tried 12
Yeah.
pi to the cube.
It's just pretty dumb. I don't like that. That's,
Another day on what do you
No,
that's gotta be kind of frustrating.
let's call up Math
Jeez.
Excel again.
Wait, doesn't it tell you when you put it in? Alright, who else?
Oh, here, I'll do the, show me an example. Do an example, see what they put for that.
I'm gonna just way up, put it in one more answer and see what it comes.
Oh, yeah.
Oh, yeah.
Takes forever.
I don't know what else to put. That seems
Here,
like,
no, I'm checking on the, show me an example, so it should show us like how it would enter it on a different problem.
when you're done, doesn't it show you what the right answers were
The
supposed to be?
speed,
Yeah, then you have to do it all over again.
yeah.
Yeah, but that's okay.
Well, I don't mind doing it over again. I'm just gonna,
Yeah, we don't want to do.
B, first time acceleration, magnitude acceleration. What? Oh, you need to put in, the maximum values are zeros, what?
So are you getting this acceleration at 0 centimeters per second squared?
oh, hang on. I know what we did wrong.
What did we do wrong?
It's not wanting the maximum acceleration. I didn't even read the question. It wants the magnitude of the acceleration when the cart has maximum speed. Well, when does the cart have maximum speed?
Zero
that's
cent.
zero.
Haha. It has maximum speed at,
That rest.
right, at those places. That's not where it has maximum acceleration.
So
It's where it has zero acceleration. The answer is zero.
Oh, that's so mad if I missed that.
Wait.
Guaranteed, it's zero.
It is,
Woo.
it
Okay,
is.
so
Okay.
position.
100%
Do you guys, does everybody see why?
Yeah,
Okay, because what we were doing,
another day off.
I understand why we did that, because we were looking at we were looking at the maximum values. Like before it asked, what's the maximum speed? So we were just kind of answering the question without really reading the question. What's the maximum acceleration? But that's not what they asked, right? Everybody see that?
Yeah.
Okay. So, okay, the positions of the cart when the magnitude of acceleration is a maximum is R. So when is the acceleration a maximum? So if we go back and look here, here's the acceleration, right? So acceleration is going to be a maximum when? Well, that's going to be a maximum when the derivative of acceleration is equal to 0, right? Everybody get that? Acceleration is v prime, so a prime is v double prime, right? Make sense? How do we find maxima and minima for a function, we said its derivative equal to 0 to get the critical numbers, right? So we're going to set the derivative of acceleration, which is v double prime, equal to 0. Well, when is sine equal to 0?
0.
At 0 and pi, exactly. So that's going to be at 0, 1, 2, 3, 4, 5, right? Make sense? Right? And the question's asking, what's the question asking? It wants to know
Positions of the cart.
the positions of the cart when the magnitude of its acceleration is maximum. So that's going to be at the integer multiples of 1 seconds, right? Everybody agree? Doesn't that make sense too? Let's think about this in terms of the cart. So we're going to pull this thing back, let's say, and let it go, right? Isn't its acceleration going to be maximum when that spring is providing maximum force, right? So it's going to be pulling hard on it. Now when it gets to the rest position, there's no acceleration, and now it's actually working against the cart and pushing on it. Maximum push, no push. Maximum pull, no pull. Maximum push, right? Does that make sense? So those are going to be at t equals 0, 1, 2, 3, 4, 5, and so we're plugging those in here, right? Well, what are the cosines of all those going to be? Are we looking for position? Position. So we go back up here to position function. So where's the position going to be at t equals 0, 1, 2, 3, 4, 5? Well, cosine of pi or 2 pi is just going to be either positive or negative 1, right? So we're getting answers of either positive 18 or negative 18. Right.
So it would just be 18.
No,
Right, so the magnitude's 18.
What?
unless it's.
Wait,
Right.
So it says the position, so wouldn't it be, do you need the negative?
The positions of the cart when the magnitude of its acceleration is the maximum is r, so it'd be 18 or negative 18.
So you need both.
I think you need both. I'd put both,
Alright.
Okay.
right?
Important, unable to contact the server.
Ah!
You didn't put a negative in there.
Oh, I didn't put a negative. Whoops.
18 and 18, huzzah!
All of you.
There we go.
Yeah, my computer could.
There we go. Okay, good.
That'd be great.
And then finally, the speed of the cart when the magnitude of the acceleration is greatest is what? I can tell you right now it's going to be 0.
Yeah.
We know that just from physics, but we could show that with calculus too, right? How's it going to be 0? Well, the acceleration is maximum when it's at its maximum displacement, right? So where were those times? Go back to our table. V double prime equaled 0 at when? Right, okay. And so what was the question? Was asking about what the speed was. Well, go to the speed function. What's the speed, or the velocity function? What's the velocity for any integer multiple of pi? 0, right? Right, the sine of any multiple of pi is 0, right? So we get, whoops, I don't want to go there. So we get 0. Oh, what am I doing? Yikes.
Here.
Very finished it.
Oh, I finished it?
You finished it.
Oh, that was it? Okay. Oh, okay. All right. Next question.
Yeah.
Okay, that was kind of a hard one. There's a lot to that one. So this one's not so hard. So it costs $8 to manufacture and distribute a backpack. If the backpacks sell at X dollars each. Now this is a little different though. The one thing that's different here, this is kind of mixed up, right? This time, instead of X representing the number of widgets, it's representing the cost of our widget, which in this case is a backpack, right? The number sold, N, is given by this function, okay? So then what's our revenue going to be? If the number sold is given by that guy right there, what's revenue always going to be? Revenue is the amount of money we're getting, right? So,
Times by X.
yeah, it can be the number sold times the price people are paying per item, right? So NX. Everybody agree? So NX is gonna be, NX is revenue.
Oh.
And then don't you have to minus 8x?
Yeah, but look here, it says it costs $8 to manufacture and distribute a backpack. So it's not gonna be 8X, it's gonna be 8N, right? So I think we switched that, right? Does that make sense? Because N stands for the number, so 8N is gonna be your cost. So revenue then is just gonna be NX minus 8N, right? I mean, yeah, it's profit is, right?
When you're two.
And then just do calculus. What's our domain gonna be for X? 0 up to infinity, right? Somewhere in there, the math gods will give us a peak. Okay, so you guys can do that one. Oh, and that's it.
It's like, John,
So what do we do?
it's like Danielle at OBS last year.
So
You could
then tomorrow, yeah, you guys can do the second part of the test, which will be practice for some people, and some people maybe it'll actually end up being, you know.
So we might be able to use that for.
Yeah, I mean, I'll grade. The first part is,
Okay.
I mean, I think we're gonna know pretty quickly when you take the test on Wednesday, which is gonna be the best test. I think most people are gonna get a better score on the test on Wednesday, personally.
Wait, yeah, so can you explain what the exact system that we're gonna use for testing part? Because we did the one before,
Mm-hmm,
that we also
So we
did
did
like the
those
first
three.
half of the paper one.
mm-hmm. That we just bailed on, except for one person.
And then we tried the second one, and then.
And then the second one,
Oh, yeah, the
Finishing
first one
the
we did,
second
and then the
one.
second one is the paper one. that
the
we
paper
did.
one, and 2 people had reasonable scores on that, and you guys can keep those. Yeah. And then so you guys, everyone will take tomorrow, everyone will just do the second part of that for practice, but some of you, if you do well on it, are actually that might be a score that, you know,
Okay,
that
so
you'll
we
keep.
would be able to have all of the test grade, be for the paper stuff, and then the optimization would just be like.
Optimization, well, I'll give you, I mean, you might as well take it and see if you can get a higher score.
Okay.
Yeah.
Fair.
See what I'm saying? And so then Wednesday we'll do the new version, and I'll give you the higher of the 2,
Okay, that makes sense.
right? But for most people, I think it's gonna be, Wednesday's really the test day.
No, I had my juices flowing when we took that second part of that test.